So today we are going to talk about neutral point in electrostatic field. Okay. A neutral point means what? It is a point where the net resultant electric field is zero. That already we have discussed and we derived it also. We have done so many numericals. Today I am going to teach you the short trick for doing this when you are appearing for any competitive exams or MCQs. Okay. So consider two charges Q1, Q2 separated by distance r. Each one case I will teach you. So first let us take Q1 and Q2 are of same nature. Means either they are positive or negative. Okay. So when they are separated by a distance r, what is the net electric field, that is where the neutral point will be there. Consider that let P be the neutral point. Okay. If P is the neutral point from A, okay, then let us consider AP equal to X. And what will be PB? PB will be R minus X, right? Well, if you do it, the net electric field at the point P equal to 0, regularly what you will do? Electric field at P equal to 0. What is electric field at P? It is due to both A and B. Then EA must be equal to EB. What does it mean? Equal and opposite forces cancels out each other. That is the meaning, right? So EA must be equal to EB. Electric field, if you calculate K Q1 square by X square, and it is K Q2 square by R minus X the whole square. This is the regular thing, you do it in numerical. But simply we can calculate with the help of this formula. What is that formula? If you just apply this, what the neutral point, for finding the neutral point X, you can apply this formula. That is square root of Q1 divided by square root of Q1 plus or minus square root of Q2 into the R, the distance between the two charges. See here, plus or minus I have given. Plus is for same nature charge. When both the charges are same in nature. That is positive or negative. If they are opposite charges, then you have to use negative symbol. That's all. With this one simple formula, you can find out the neutral point. Not only neutral point, you can find out the equilibrium also. That I will discuss later. Now the neutral point is this point. So each case we will analyze. So what is the neutral point? Neutral point, if I ask for MCQs, not for CBSE exam. MCQs, just remember this formula. So let us see one by one. Consider Q1. Both are positive. Okay. So what will be this? Say for example, if I take 5 microcoulomb and this is 10 microcoulomb. Okay. What will be your neutral point? Where is the neutral point? Let us take neutral point is P. Okay. So neutral point if you want to, neutral point distance if you want to calculate. X is given by square root of Q1 divided by square root of Q1 plus Q2. Why Q1 plus Q2? It is same nature, right? Plus. Okay. So how much it will be? It is nothing but here distance I have not given, 2 centimeter you take. Okay. So what it will be? 5 into microcoulomb, right? So 5 into 10 to the power minus 6 divided by 5 into 10 to the power minus 6 plus square root of 10 into 10 to the power minus 6. Usually I should not take these values, then it will be very difficult. In competitive exam, don't worry, they will not give such kind of values because you are not allowed to use calculator. So they will be giving like 16 okay, microcoulomb and 4 microcoulomb. Okay, so now this will be easy for you. So this is nothing but 16 microcoulomb divided by 16 micro plus 4 micro into 2 centimeter. So how much it will be? It will be very easy. All the micros will cancel out each other. Then what is remaining? 16. 4 by 4 plus 2 into 2 into 10 to the power minus 2. That is nothing but 4 by 6 into 2, 10 to the power minus 2. That is 4 by 3 into 10 to the power minus 2 meter, or X is nothing but 1.33 centimeter from Q1. Remember, here whenever you are writing this formula, this distance will be always from Q1 because Q1 we are considering. That's why Q1 is in the numerator. So that point you should not forget. Okay. So this is one example I have shown. Now, what happens when two charges are of equal magnitude? It's very simple now. Already you know that it will be at the midpoint. If you take r is the distance, then the neutral point will be at the midpoint. When two charges, when q1 equal to q2, neutral point will be at r by 2. So we know that, but with this formula it will be easy. So you can apply and check. I will give it as homework. I don't want to waste your time. So the next one is unlike charges. In unlike charges, you know that where the neutral point, like charges, the neutral point lies in between the charges, that is internal point. Okay, for like charges, the neutral point lies in the internal point on the line joining the charges, right? Because due to this, if you keep a positive charge here in order to find electric field, due to A it will be this way and due to B this will be in this way. So opposite forces, so the net force will become 0 at any point. If it is equal midpoint, otherwise it will lie nearer to the smaller charge. Always remember the neutral point and it will be closer to the charge in smaller magnitude. Smaller magnitude only. I am not talking about the sign. Whatever is small in magnitude, nearby to that, the neutral point lies. So that point you should never forget. For unlike charges, if you calculate, see Q1, Q2, we know already. All these discussions are over in our class. So if you consider the point P, what will be that? Place positive charge here, unit positive charge due to A. What it will be? Here I have considered Q1 is nothing but minus Q2. Okay, and they are not equal. They are opposite in nature, unlike charges. Okay, so what will happen? This positive charge will be repelled. So EA will be this side and EV will be attractive because negative, right? Q2. So if it is an addition, you cannot cancel it. So the neutral point lies external. Lies in the external point. Lies on the external point. On the line joining the two charges. So what it is? Q1 and Q2 are here, and if you want to find out the neutral point, first and foremost thing is what? Check the magnitude of Q1 and the magnitude of Q2. If Q1 is lesser than Q2, then the neutral point will lie near the Q1. Correct? So this will be the neutral point. So what will be this distance? This distance is x, this distance is d. So ordinarily you can calculate it. At this point EA will be, at point P you can write EA will be equal to EB. And if you forgot the procedure, you can just formula. If you forgot, then you can use this. What is EA? K cube by x square. That will be here. It is K Q2. Q1, Q2 by P plus x the whole square. Then further with the given values, you can solve it easily. It will take maximum 1 or 2 minutes. But with the formula, we can quickly calculate. What is the formula I told you? See, the formula is nothing but simply this simplification of this result. If you just expand this and simplify it, you will get that result. That's not a big rocket science. Now, x is equal to what? Square root of Q1 by Q1 minus Q2. Because unlike charges, right? With this help, you can find out this one. But this point lies external and closer to the smaller charge. Lies external and closer to the smaller charge. But when you apply this formula, this distance will always be from Q1. Because numerator we are taking Q1, so this distance will be always from Q1. But you should remember that it lies near, closer to the charge of smaller magnitude. But when you apply this formula, it will be from Q1. That point alone you need to keep it in mind. Hope this is clear for you. So electric field, you are having what? I will summarize that. Only one formula. What is that formula? Or only formula I can teach you. See, this is You may not learn this. This is the same formula, but for the simplification, if you do it, you will get this. This is special case you can apply. First special case is an exception. Okay, this is very important. See here, when Q1 is equal to Q2, okay, but opposite in nature. This is an exception that you must remember. Readily you can do that. So Q1 must be equal to Q1 is equal to Q2 equal to Q. Both are equal but opposite in nature. In that condition, what will happen? Apply that formula. So on application of the formula, see what is the formula? Q1 by square root of Q1 minus Q2 into R. Correct? What is Q1 ma? We have taken Q, equal charges, so magnitude will not change. Q minus Q is 0. So anything divided by 0 will give you infinity, not defined. So this is an exception if you have equal and opposite charges. If you have equal and opposite charges, then neutral point will be at infinity. So the next one case is when one charges, when Q1 or Q2 is multiple of each other. Okay, any one charge you take, so Q1 is multiple of Q2 or Q2 is multiple of Q1. Say for example, 5 microcoulomb you are having and here 10 microcoulomb you are having. That means what? The Q1 is 2 times lesser than. Now otherwise Q2 is 2 times that of Q. Right? So how many times? Q2 is 2 times of Q1. This 2 is called N. So Q2 can be written as NQ1. So in general what I can write? Q1 I will take. Q2 I will be taking as NQ. Okay, NQ1 only you write. Q1, Q2 you should not. This is Q1, this is Q2. But what we are going to take now, this is a special case, right? So I can take this as when Q1 is taken as, let me redefine it because it will be confusing. Now, Q1, Q2. So take Q1 as Q, that is 5 microcoulomb. Q2 can be written as 2 times that of Q. So that 2Q I am writing it as what? NQ. So this will be proper. So 2 charges of same nature. Plus or minus, okay, but one charge is the multiple of other charges separated by a distance means here you can use what is that formula? It's very simple formula. It is nothing but R by 1 plus root n when the charges are of same nature, where R is the distance between the charges. Okay, so this is the formula. Directly you can substitute it. Here what is the simplification we have done? Instead of calculating Q1, Q2 everything, we have just directly substituted the n value. That's all. Okay, so what about negative? If it is plus Q and minus NQ, what is the formula? Then it is simple. Neutral point will be what? R by root n minus 1. The root n, remember, must not be lesser than 1. So you should be very careful. Okay. So this is the formula for neutral points in electric field. Hope this is clear. So now we will move to the electric potential. See, when we talk about electric potential, it is very clear. Where will be the zero potential, ma? Okay, when two charges of same nature correct? Resultant potential cannot be zero on the line joining the two charges, right? Why? Take for example A point, B point where Q1, Q2 are there and you are going to find out equal, not equal, same nature charge. So let us consider a point P. If you want to find out the potential at the point P, then it will be due to what? Both A and B. Both are same nature. Same nature means only addition you will do it. When you add it, it cannot be 0, right? Minus 5, minus 5. Same for example, minus Q1, minus Q2. If you add, again it will be the summation. You are not subtracting it. So the zero potential cannot be obtained on the line joining the two charges in the internal point. So the only possibility where it is at infinity, you can expect the neutral point. So straight away you can write electric field zero potential for two charges of same nature. It will be at infinity. Okay. What about opposite charges? Of course it is possible, but we have learned that two neutral points will be there. So one will be in the internal point, one will be in the external point. But remember that both the points will be closer to the smaller charge, that is charge of smaller magnitude. Always that condition will be there. So in the internal points, if you want what it is for internal points, let us consider that this is Q1, Q2 and magnitude of Q1 is lesser than magnitude of Q2. Always for opposite charges you should consider this. Now we know that it is Q1 is lesser than Q2. The neutral point must be closer to the Q1. That we know that. So what is the formula? It is very simple even if you do with the regular thing. So at the point P, what is the potential? Potential should be 0. That means VA should be equal to VB. If I take these two as this thing. Because equal opposite, right? So now what will happen? Here it is due to what? K Q1 by what is the distance? X if you take it is X. This is K Q2 by R minus X. The total distance is R. So if you just do this math, what you will get? Q1 by Q2 will be equal to X by R minus X. So on simplification, what you will get? If you forget, then you can use this way. Otherwise, just learn that final formula. Okay. So what is, we need X. So RQ1 minus XQ1 must be equal to Q2X. So RQ1 will be equal to, if you bring this XQ1 this side, Q1 plus Q2. So we need X. That is nothing but Q1R by Q1 plus Q2. Simple, right? This is for internal point. Okay. For external point. External point also we know that the neutral point will be closer to the smaller magnitude. Here Q1 is smaller. So the external point P at this point it will be 0. So what is this distance? D plus X. So VP must be equal to 0. That is VA will be equal to VB. I am not going to explain all those things. So it is simple. K Q1 by X must be equal to K Q2 by D plus X. Because I have taken, you can take R also, not an issue. So KK will cancel out. So Q1D on cross multiplication, Q1D plus Q1X will be equal to Q2X. So Q1D will be equal to Q2 minus Q1X. So we are finding X, that will be nothing but Q1D by Q2 minus Q1. If I take D, you may get confused. So I am just going to use only one formula. So you can write R only. So in that way, you will never forget. Unnecessarily two variables we denote. So R plus X. So R. The same formula, right? For internal point plus. Okay. For external point it is minus. So this is the thing. For neutral point, electric field and magnetic field. You can practice with some of the numericals given in the previous year NEET or CBSE questions. But for CBSE, steps mark will be there. So don't forget to do with steps. Hope this is clear.